Hello, today me Priyanka Dandapat and my teammates Mohit Jain and Ayush Gupta are going to present our project on home light automation using Arduino and Wi-Fi. First of all, what is home automation? Home automation refers to the monitoring and controlling of home appliances remotely, so you can make the devices automatic and workable with less human intervention. This has become popular over the years due to the availability of wireless routers or internet and smartphone app control devices, and also the fact that it has become more affordable and easier to use. There are many benefits to home automation system, like it increases safety and security. Some examples can be motion sensors at your front door, which can like on the cameras and other things. Home automation is also very convenient. You can turn on light and fan of a room using the motion sensor that whether someone is in the room or not. Then reduce heating and electricity bills, reduce carbon footprints, flexibility and customization, and peace of mind are some other benefits. Different ways of implementing home automation system. There are many different technologies available nowadays, but these are some common ones, like the Bluetooth based ones, which can connect the cell phones and the devices in your home and like automated. Home automation system using Android application. Again, smartphones will be in use here. Home automation system based on gesture human machine interface, and then using voice recognition. IoT based home automation using Intel Galileo board, and then home automation using speech recognition and machine learning, and then electrooculography signal. So these are some different types of home automation systems.
So I am going to explain hardware components used. So first of all, we use Node MCU. The ESP8266 Node MCU V1.0 ESP12E Wi-Fi module can be used as a Wi-Fi enabled replacement for an Arduino in many applications. Node MCU is an open source firmware for which open source prototyping board designs are available. Aside from adding Wi-Fi capability, the main advantage of the ESP8266 processor over the standard Arduino EVR processor is that it has larger 4 MB flash memory and runs at clock speed of 80 MHz, which can sometimes be optionally overclocked by 160 MHz, resulting in a very fast processing speed. The second component is breadboard. The breadboard is a wide rectangular board with small embedded holes to insert electronic components. Breadboard is also categorized as a solderless board. It means that the component does not require any soldering to fit into the board. The top and the bottom holes of a row in a breadboard are connected horizontally, and the center part is connected vertically. It means a single horizontal line of a breadboard has the same connection. The vertical connection of the center part means a single vertical line in a breadboard provides the same connection. The two top and bottom parts of the breadboard are generally used for the power connections. Third component is LED. An LED is a semiconductor device that emits light when an electric current flows through it. When current passes through an LED, the electrons recombine with holes re-emitting the light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. LED has a wide range of applications ranging from your mobile phone to large advertising billboards. Some of the software used in this project are Arduino IDE, HTML coding for web page, etc. So first of all, Arduino IDE. This is an open source software for writing and uploading code to Arduino devices. The IDE program is compatible with a variety of operating systems, including Windows, Mac OS, Linux, etc. It is compatible with the computer languages C and C++. To upload the sketch created in the Arduino IDE, we must connect the Genuino and Arduino board to the IDE. HTML coding for web page. HTML stands for Hypertext Markup Language, which is the most widely used language on web page to develop web pages. HTML is used to create a website or customize an existing web template. Web hosting on Wi-Fi. Web hosting is an online service that makes your website's content accessible on the internet. Self-hosting entails setting up and configuring a web server from scratch, including the equipment, hardware, and software. In our case, we will be hosting the website on our local Wi-Fi.
Now coming to methodology. First, you have to set up the Arduino IDE and install all the required libraries. So in order to able to program the ESP board, you need to first configure the Arduino IDE. So once the ESP environment is ready, next you have to add the required libraries for remote ME connection. So open the Arduino and then go to Sketch. Like these are the steps. Go to Sketch, include library, and then manage libraries. A pop-up window will show where you have to search the required libraries and install them one by one. Then you have to create the sketch. Sketch is nothing but the code that you have written in the Arduino IDE. So you just write the code and then you upload it in Arduino. The code can be in any language like C or C++, Java, whichever you're comfortable with, and the Arduino also supports that. So then you can connect the Node MCU with breadboard and LED. Next, we are going to create a website using HTML language, which have the commands for the automation of different home appliances. Like in our case, if we have LEDs, then we are going to use the HTML language to create a website which has options for like turning on the LED and then turning off the LED through your mobile phone. Next, you have to host a local server over like your Wi-Fi and connect the mobile over it, so that whatever commands, whatever like buttons you press on that website created through HTML, those commands can travel to the LED and then it can automatically turn on and off. Then, yeah, so that's basically the thing that is going to happen over here. Now, Ayush Gupta will give you the overall overview of how the things are going to work in hardware.
Greetings sir, this is Ayush Gupta and today I'll be demonstrating you our model on Wi-Fi based home automation. So for this model we are using an ESP8266 board on a Node MCU chip, and we are using a relay board to give a power supply of 12 volts to our LED strips. So what this model is doing is, uh, as soon as I turn on my Wi-Fi, this Ayush Wi-Fi or hotspot, this model pings to all the nearby Wi-Fi and connects to the one with the highest ping, and thus connecting to the strongest Wi-Fi in the given list of multiple Wi-Fi. So that is the first task of the model. And then as soon as you are connected with a stable Wi-Fi, it will generate an IP address and it will host a site on that IP address like this. So if you are connected to my hotspot or a common Wi-Fi, basically you can interface with this device, and this device has kind of a very user-friendly interface which I have built using basic concepts of HTML and CSS. So let's see it in working. So now I've reset the board and you can see that it is searching for the strongest Wi-Fi in the nearby proximity, and it connects to my Wi-Fi as it is the strongest in the range and generates an IP address. This IP address is customizable and we can customize it using the IP address or local IP address, uh, dedicated IP address or something like that, and we can generate IP address based on that. So now my laptop is also connected with the same host I use. So when I log in, it will generate this error message because we haven't yet logged in into the file after resetting. So as soon as we log into the system, it will generate this page. Now using this page, we can directly control the lights using all on, all off, or any other features that we want. And with respective calls, it is sending a hyperlink call to the board, which in turn does the required function and gives acknowledgement in the serial monitor. See, now I will do all off. It will give an all off root successful and all off root successful, all on root successful. So what's happening over here? First of all, we have different sections of memory in this USB266 board, which holds stuff like index.html, which is this home page, error.html, the error window that we saw, and also login.html, the login window that was there. And also it has features like OTF, over the air. This feature basically allows us to upload code over the air without any wired intervention to the server itself on the same IP address that we showed earlier. So that is one thing. And next we have a set server function, which basically helps us to set the server and like create these call variables like handle the login, handle lamp, handle root, and then what happens if we want to override and we want to change the password. So in that case we have all these functions, and these functions are defined here. Like whenever we call all on, so what happens is that it prints an all on acknowledgement on the same monitor as we saw here, and also it basically acknowledges the message, the hyperlink which we got, and then based on that hyperlink it generates an error window if the login is not there, or it generates a successful window and calls the root or the index.html file again and does the operation of turning all the lights high. So as you can see, this is a very basic implementation of this thing, like turning pins high and low using Wi-Fi. We can also do multiple stuff like measuring different sensor values over the net. So that will help us to make a local area network using the same module, and also help us to interact with different boards. So that is one thing that we can do, like creating an agriculture based system that takes values from, let's say, a humidity sensor or a DHT module maybe, and then based on the values it will project those values on a site, as well as it will do the necessary operation of providing water, turning on some exhaust fans in the greenhouse, or like other like basic stuff. So this is a good home automation project or the automation project in general, and we can connect multiple lights or multiple devices on multiple pins using the same relay concept, and you can create a good or good home automation system in the cost of around 800 to 900 rupees, which has the market cost of around 7 to 8,000. So this is quite cost efficient also. And yeah, that was our Wi-Fi based home automation model, and we'll now move to the PDF and in-depth explanation of each of the parts, like the Node MCU, relay modules, lights. So thank you so much, sir, for listening. Have a great day.